The molecule that I received was nitrogen trifluoride, so that consists of 1 nitrogen and 3 fluorines. So it is NF3. So to find it on the periodic table, you'll look through there and you'll start in the S block, which would be 1s2, and then you'll go to the next one, which is 2s2, and then you'll see that when you get to that P block, you will see that it is the third element in for nitrogen, so it's 2p3. Then you'll repeat that same thing with fluorine, where it is 1s2, 2s2, 2p, and then you'll see that it is the fifth one in. Okay, so when looking at the electron configurations in the elements of nitrogen and fluorine, you can see on the periodic table that nitrogen has 5 valence electrons right there, and then fluorine has 7. So go back down here. So with the 5 valence electrons in nitrogen, we're going to just place them. So some of them are paired, except for that one loner 5 there. And then the fluorine has 7, so you can do this, and you'll put 7 around the fluorine. And then you can see that neither of them can satisfy the octet rule by themselves. So you can see here on nitrogen there should be 2 more and then 1 more here. And then in fluorine it has room for 1 more. So together, nitrogen has 5, so you do 5 here, and then fluorine there's 3 fluorines with 7 each, and then you multiply that together, and in total they have 26 valence electrons. If you look over here, I have already arranged it, so there's the 3 fluorines that we have from NF3, and then the 1 nitrogen. So just to kind of even it out, as you know, with fluorine having room for just 1 more valence electron on each of the fluorines, you can see that nitrogen has the 3 that could be kind of moved around. So if you do this, you can connect these here and take away these 2 valence electrons just so it looks neater. Like I said before, and back to the original drawing with the nitrogen's original outer shell, you can see that nitrogen has those 5 valence electrons and still has room for 3 before, pairing up with fluorine, and then fluorine still has that room for 1. So that means that the valency of nitrogen would be 3, and then the valency of fluorine would be 1, because nitrogen has room for 3 more valence electrons, and fluorine has room for 1 more. If you look at the chart of the different electronegativities for the elements, you can find nitrogen and fluorine both on that chart, and so you'll see up here is nitrogen, so the electronegativity of nitrogen is 3.0, and then fluorine has an electronegativity of 4.0, so that means that the most electronegative one would be fluorine with that 4.0 found on the chart up here, and the nitrogen would be the least electronegative. Judging by periodic trends, you can follow going down periodic table this way. You'll see that the radius of the element will increase, so the size of the atom will increase, and then going from left to right here, that means that it's decreasing in size. So if you see where nitrogen and fluorine are, they're both on that same line number 2, n equals 2. So you'll see that nitrogen comes first, and if you follow this here, on the bottom, the decreases, you'll see nitrogen comes first, then fluorine. So the leftmost element would be nitrogen, rightmost would be fluorine, which means nitrogen would be the larger of the two elements. So, to assign formal charges for each element, you can go back to your Lewis dot structure and we'll do it. We'll start with nitrogen. So, first you have to find how many valence electrons nitrogen has. We already determined that nitrogen has 5 valence electrons. So then you're going to subtract the non-bonding valence electrons. So, how do you find that? Well, you see up here that these two up here are the only two that aren't bonding. So then you'll subtract 2 from 5, and then you're going to look at the bonding electrons divided by 2. So let's go back down here and see how many bonding electrons nitrogen has. So here's 6. Nitrogen has 6 bonding electrons. So we can pencil that in up here, and then you'll see that 5 minus 2 minus 3 is 0, which means that nitrogen has a formal charge of 0. So then you can look at fluorine. So fluorine will do the same thing where we start with how many valence electrons they have. Fluorine has 7, as we've said before, so you're then going to subtract the non-bonding valence electrons. Well, how many bonding valence electrons do we have here? We have 2 bonding valence electrons on all the fluorines, of course, but we're just calculating it for 1. So, let's see. We'll put that over here where the bonding ones will go. And then the non-bonding valence electrons. You see you have 2, 4, and 6. So, you'll put that in the formula where the non-bonding ones go. And so 7 minus 6 minus 1 is going to be 0. So once again, we have a formal charge for fluorine of 0. So all of the fluorines will have that same formal charge. And then, so as you can see, nitrogen and fluorine both have that formal charge of 0. Going back to this table of the increasing and decreasing electronegativity, you will see that, like we said earlier, nitrogen has that 3.0 electronegativity and fluorine has that 4.0, which means that there's a 1-point difference between the two of them. It's not greater, not less than, it's just 1, which means that on this Lewis dot structure here, you can see that all 3 of these bonds here are going to be polar covalent bonds, just by definition, because of that electronegativity not being any more or any less than 1. So then, to figure out if the molecule has any resonance structures, you can see that if you just move these around, there's not going to be any difference with the bonds, because it's always going to be a nitrogen and a fluorine bond. And so there's not going to be any type of resonance structure, because no matter how you arrange it, it's just rotating the fluorine like one to the left or right, and it's not going to change the overall structure. So, to identify the shape of the molecule of each central atom, you will look here and see that nitrogen is your central atom here, and so nitrogen has this one lone pair which brings you into this section here, and then you'll see that nitrogen also has 1, 2, 3, 4 bonds. So then you can look through here, and where does that cross? Right at this trigonal pyramid. So, to draw the trigonal pyramid, you'll put this in N here, do this little triangle with the fluorine, and then you'll put this fluorine over here, and then you'll put a dashed line or triangle with the fluorine over here. Don't forget your 2 lone electron, or the 1 lone electron pair, And that is your 3D shape.